Now we're going to look at the following problem. The vertices of a quadrilateral are listed below. Show that the quadrilateral is a parallelogram and find its area. A is going to be 5, the point 520. B is going to be the point 261. C 247. And the fourth point D is 506. So I'm going to try to draw a rough sketch of what this quadrilateral looks like. Please keep in mind that I'm doing the best I can. I don't draw very good three-dimensional pictures, but you could plot these points in a graphing program. I use a program called GeoGebra, which is really nice and helpful, and it'll help you see this quadrilateral. But the rough sketch of what this quadrilateral looks like. A is over here, and then you have B. Well, you have A, and you have B here, and then you have D and C here and here. So it looks something kind of like that. So the first thing we need to do is verify that this is a parallelogram. So a parallelogram, the sides are parallel. And so I'm going to look at the vectors. I'm labeled as C and D. I'm going to look at the vectors AB, and CD, AD, and CB. So I'm going to look at the four sides here. And remember that you subtract terminal minus initial. So it would be -341. CD would be 3, -4, -1. AD would be 0, -26. And CB would be 0, 2, 6. So if you notice, these two here, I just multiply by -1 to get to the other. So these two vectors they're parallel. And the same thing here, if I multiply one by -1, I would get the other. So these vectors are parallel, which means that this quadrilateral has parallel sides. Therefore, it is a parallelogram. So this is a parallelogram. So now, what I need to do, if I go back to the problem, I was asked to show it's a parallelogram, and I need to find its area. So to find the area of a parallelogram, remember in our geometric properties, there's a way to find this using the cross product. So I need to take two vectors that form adjacent sides. So if I look here, if I take the vector AB, take this vector right here, that'll be this side right here. And then if I take AD, that will be the other side of my parallelogram. So I'm going to compute the cross product of those two vectors, AB crossed with AD. So I, J, and K, and then put in My vector AB was negative 3, 4, 1. And my vector AD was 0, negative 2, 6. And you're going to compute this cross product. So we've computed several cross products, so I'm going to skip over the computation. This is 26I plus 18J plus 6K. And then to find the area of this parallelogram, I just need to take the magnitude of this cross product. So the square root of 26 squared plus 18 squared plus 6 squared. It's the square root of 1036, and you could leave your answer like that. Or if you were approximating it, put it in a calculator, it's approximately 32.19. And that would be the area of this parallelogram.